In order to perform the experiment, we have to go to the engineering laboratory to get the equipment and materials needed.
Set the two towers 1 meter apart and make sure that the receiving antenna is set for horizontal polarization. Mount the Yagi boom onto the antenna mount and place a single dipole on it as shown. Make sure to not tighten the screw so it can rotate freely. Extend the ends of the elements of the dipole so that its length will be 10 cm in total. Using the black cable, plug it into the receiver and generator port of each tower. Using the USB to Mica 8 interface, connect the cable into the generator and the computer. Attach the receiving antenna to the receiving antenna tower. When all hardware connections are done, turn on the power to the generator and the motor enable switch. The generator antenna should rotate and then stop. Open the Spile software from the computer and launch the 57200 antenna lab. Choose Effect of Surroundings. Choose Practical 1. Open the rotor or generator controller. Press antenna to zero function. The generator antenna moves and then stops. Align the dipole so that the side of the dipole faces the receiving antenna. Connect the coaxial cables of the dipole and generator. Set the value of frequency to default value of 1500 MHz. Open the real-time signal display and check if there's a signal present. The bar represents the strength of the received signal. Put your hand between the antennas. Notice how it affects the signal to decrease when your hand passes through. Place your hand in different positions. Note how it has significant effect on the apparent path loss between the two antennas.
Presentation of results. For real-time signal without hand obstructions, it shows both the setup with any hand obstructions as well as the real-time signal acquired by the dipole. The received signal strength has an approximate value of 47.1 dB. This is a maximum signal strength acquired when there are no obstructions between the dipole and receiving antenna. For real-time signal display with hand obstruction between two antennas, it shows both the setup with hand obstructions in the middle of the dipole and receiving antenna, as well as the real-time signal acquired by the dipole. The received signal strength has an approximate value of 42 dB. This is the signal strength when there is a hand between the dipole and receiving antenna. For the last part, real-time signal display with hand obstructions near the dipole. It shows both the setup with hand obstructions near the dipole as well as the real-time signal acquired by the dipole. The received signal strength has an approximate value of 29.3 dB. This is the signal strength when the hand is placed as near as possible to the dipole.
This practical acted as an extension from the previous experiment concerning the dipole antenna. The activity allowed the students to interact with the dipole setup and explore the effects of surroundings to the RSL of a given dipole setup. The results showed that the control setup reads an approximate signal level of 47.1 decibels. Upon introduction of an object, in this case, one of the students' hands, the signal level decreased by at least 10%. This was given that the hand was positioned approximately halfway between the transmitting antenna and the receiving antenna. In addition, the hand that was placed as close as possible to the transmitting antenna revealed a reduction of approximately 38% in the RSL. Based on the data, the appearance of an obstruction directly in the path of the transmitting and receiving antenna directly affects the received signal level. Moreover, the distance of the obstruction with respect to the transmitter seems to have a relationship with the attenuation of the signal. An intrusion that is as close to the transmitting antenna as possible provides the maximum attenuation at the receiver. Unfortunately, the condition where there is an object that is placed as close to the receiver as possible and farthest from the transmitter was not explored. As such, it would be desirable to confirm whether the conclusion is true in a further experiment.
Set the two towers 1 meter apart and make sure that the receiving antenna is set for horizontal polarization. Mount the Yagi boom onto the antenna mount and place a single dipole on it as shown. Make sure to not tighten the screw so it can rotate freely. Extend the ends of the elements of the dipole so that its length will be 10 cm in total. Using the black cable, plug it into the receiver and generator port of each tower. Using the USB to Mica 8 interface, connect the cable into the generator and the computer. Attach the receiving antenna to the receiving antenna tower. When all hardware connections are done, turn on the power to the generator and the motor enable switch. The generator antenna should rotate and then stop. Open the Espio software from the computer and launch the 57200 antenna lab. Choose Effect of Surroundings. Choose Practical 2. Open the rotor or generator controller, then set a default frequency of 1500 MHz. Then open the radiation pattern plotter to make a plot of the dipole to see what the plot will be under normal conditions. Next, take hold of the metal sheet and position it to the side of the dipole at about 45 degrees, pointing it towards the receiving antenna. Ensure that the overlay option is ticked on the plotter, then click Plot again.
In the setup, there are no obstructions such as the metal sheet. It is only the dipole and the plot of it in the radiation pattern. In the next setup, having an obstruction already, which is the metal sheet, based on this result, at 0 to 1 degrees the signal is around 49.4 decibels, while at 90 degrees the signal is around 16.7 decibels. In this setup, it shows the setup with the metal sheet facing the generator tower at 45 degrees. Based on this result, at 0 to 1 degrees the signal is around 44.8 decibels, while at 90 degrees the signal is around 16.4 decibels. For the next setup, it shows the setup with the metal sheet facing the generator tower at 45 degrees. Based on this result, at 0 degrees, the signal is around 48.3 decibels, while at 90 degrees, the signal is around 14.8 decibels. For the next setup, with metal sheet directly between the receiver and generator tower, as well as the radiation pattern plot acquired by the dipole. Based on this result, at 0 degrees, the signal is around 28.1 decibels, while at 90 degrees, the signal is around 13.2 decibels. And for the last setup, with a metal sheet positioned at the back of generator tower, as well as the radiation pattern plot acquired by the dipole. Based on this result, at 0 degrees, the signal is around 55.6 decibels, while at 90 degrees, the signal is around 14.5 decibels.
For this laboratory exercise, the effects of obstructions to the received signal level was explored. The particular obstruction used in the experiment was a large metal sheet, positioned at various locations around the antenna. In addition, measurements were taken without any obstruction. These measurements served as a baseline comparison for the performance of the dipole antenna with a metal sheet. There were two notable metal sheet positioning during the experiment. First position is when the metal sheet is positioned directly in between the transmitting antenna and the receiving antenna. The maximum and minimum RSL of the system under this condition was reduced by at least 43% and 20% respectively. Second position is when the metal sheet is placed in the opposite direction of the receiving antenna. For this condition, the measured maximum RSL was increased by 12.55% and the minimum RSL was reduced by 15%. Referring to the collected data shows that the metal sheet either impedes the signal transmission or aids it by reflecting the radio signals. By placing the metal sheet directly in between the transmitting antenna and receiving antenna, causes the radio waves to be reflected away from the receiving antenna. Moreover, referring to the previous laboratory experiment, where the dipole antenna's radiation patterns were explored, shows that the horizontal-oriented dipole transmit the signal in two directions. Placing the metal sheet in the opposite direction causes the radio waves that are transmitted opposite to the direction of the receiving antenna to be reflected in the right direction, thereby amplifying the signal in one direction and increasing the directivity of the antenna.